Now you've given us the background here, could you talk about your study? What did you do?
In our study, what we wanted to do was investigate this tendency of bevacizumab to interact with silicone oil droplets by comparing two types of syringes. Syringes which had the usual silicone oil used as a lubricant, and syringes which had a silicone oil which was cross-linked to the surface of the barrel of the syringe, meaning that it couldn't be extracted out of this barrel. So our main hypothesis was that these cross-linked silicone syringes would induce less aggregation, less modifications of the antibody, so that therefore it wouldn't impact its stability compared to normal silicone oil lubricated syringes.
Hmm, interesting. Could you say a little more about how you did this?
To investigate our objective, we filled a several amount of these syringes of each type and then stored them for up to 3 months in two different temperatures. The usual refrigerated storage conditions and so at 5 degrees, and a heat stress condition at 35 degrees, which was what we call an accelerated study. And then at determined intervals of time, we extracted some of these syringes from their storage departments and subjected the content of the syringe to a several amount of physical chemical assays. Namely, we investigated the aggregation index of the solution. We performed size exclusion chromatography on them, did subvisible particle counting, dynamic light scattering, and also the classical visual examination of the content.
Hmm. So those techniques that you mentioned, is it fair to say that they are all techniques to estimate the numbers of particles and the sizes of particles formed?
Now, what these essays allowed us to understand, or to at least gain insight into, was indeed the number of particles, their size, but also how the antibody behaved. Did it fragment, or did it aggregate into um, high molecular weight species, which hadn't, for example, quite yet formed particles?
So what did you find?
The main result of our study was that the physical stability of bevacizumab solutions, that means how intact they stayed, shall we say. So this physical stability seemed to be superior with the cross-linked silicon syringes compared to the classical normal silicone oil lubricated syringes. Indeed, we showed that there were less particles, that the bevacizumab was maintained its initial nature. It didn't fragment, didn't associate itself, and all those elements pointed towards the fact that um, these differences would be probably likely linked to the presence of the silicone oil because that was basically the main difference between these two syringes.
hmm And what were your conclusions?
Well, I think the main conclusion, what can all be drawn from this, from a pharmaceutical point of view, is that it shows yet again that choosing the right primary container for monoclonal antibodies, or in fact any medication, really remains primordial if we want to maximize patient therapeutic safety. That's really the main point.